You might not think twice about the objects you use every day, like a paperclip, a spoon, or even a glass of water. But behind these simple things is a world of physics, full of forces, energy, and hidden principles that make life as we know it possible. Today, we're going to explore the physics behind some everyday objects and show you how they work on a level you probably never considered. Let's start with the humble paperclip. It seems so simple, right? But when you look closer, it's an excellent example of how forces like tension and elasticity come into play. The paperclip is made of metal, typically steel, which has an ability to bend and return to its original shape thanks to its elastic properties. When you bend it, you're temporarily stretching the metal's molecules. But when you release it, those molecules spring back into place, holding your papers together. This is a great example of Hooke's law, which states that the force needed to stretch or compress an object is directly proportional to how much the object is stretched or compressed, up to a certain point. For the paperclip, this means that it will only return to its original shape as long as you don't bend it too far, otherwise, you might break it. Next, let's talk about a spoon in a cup of coffee. Ever notice how the spoon seems to bend when you stir hot coffee or tea? It's not magic, it's the result of thermal expansion. When the spoon heats up, the molecules in the metal start vibrating faster and take up more space. This makes the spoon appear to warp and bend, even though the material is still solid. This effect is actually more pronounced in some materials than others. Metals, like the one the spoon is made of, expand significantly when heated. The warmer the coffee, the more the spoon will bend. Speaking of elasticity, let's take a look at a classic, the rubber band. A rubber band behaves according to Hooke's law just like the paperclip, but in this case, we see something more interesting. When you stretch a rubber band, it gets longer, and the force you apply to stretch it is directly proportional to how much it stretches, until you reach a breaking point. But what happens when you let go? The rubber band snaps back to its original size because the elastic potential energy stored in it gets released. That's why rubber bands can be so handy, storing energy in a small, stretchy form. It's a great example of how materials can store energy and release it when they return to their shape. Now let's talk about something we've all experienced: breaking glass. You're sitting at the table, and suddenly, a glass slips off and shatters into a million pieces. Why does that happen? The physics of impact and force are at play here. When the glass hits the floor, the force of the impact is concentrated at a single point, and because glass is a brittle material, it can't absorb that energy without breaking. In physics, this is explained by the concept of stress and strain. Glass is strong when forces are applied evenly, but it's weak under concentrated pressure. So, when it hits the ground, it shatters because it can't redistribute the energy from the impact effectively, and cracks form almost instantly. Inflating a balloon is another everyday activity with a surprising amount of physics involved. When you blow air into a balloon, the air molecules inside push against the walls of the balloon. The more air you put in, the more the balloon stretches to accommodate the extra volume. This is a great demonstration of Boyle's law, which states that when the pressure of a gas decreases, its volume increases, provided the temperature remains constant. So, as you blow air into the balloon, the air pressure inside increases, making the balloon expand. If you keep inflating it, eventually, the pressure inside will be so great that the balloon can't hold anymore, and it'll pop. Finally, let's talk about liquids, specifically water. Ever wonder why it's so easy for water to flow from one container to another? This is thanks to gravity and surface tension. Water molecules are attracted to each other, which creates surface tension, allowing the water to stick together and flow smoothly when tipped. Gravity then pulls the water down, making it easy to pour. The surface tension is also why small water droplets can form and sit on a surface instead of immediately spreading out. It's the result of water molecules pulling towards each other, creating a sort of skin on the surface. This allows water to flow without splashing too much, unless, of course, you tilt the glass too fast, so, There you have it, some of the basic physics behind everyday objects and actions we take for granted. The next time you pick up a spoon, stretch a rubber band, or even pour a glass of water, remember, these simple actions are all governed by fascinating principles of force, energy, and matter. The world of physics is always around us, and it's often in the most unexpected places. The physics of everyday objects isn't just about understanding the world around us, it's about seeing the wonder in the small, everyday things. Thanks for watching, and remember to keep exploring the science that surrounds you every day.